All right, Pac-Manian. Last page of 11.5 before the homework. Kind of some cool stuff here to look at. We've got this architecture's art or science of designing buildings and structures, so they're going to bring this in. So let's read it, check it out, and then we'll answer the last problem. So the Cube House of Rotterdam in the Netherlands, shown at the top right, were built in the 1970s. Each cube is a house tilted and resting on a hexagon. How many sides? 6. Good. Shaped pylon and is meant to represent an abstract tree. It kind of does look like that, I guess. The village of a cube house of cube houses creates a forest. So very cool. The Nakagin Capsule Tower, shown at the right, is an office and apartment building in Tokyo, Japan, made up of modules attached to 2 central cores. Each module is a rectangular prism connected to a concrete core by 4 huge bolts. The modules are office and living spaces that can be removed or replaced. That's pretty cool. So, go deeper. Use the information to answer the questions. There are 38 cube houses. Good. Each house could hold 1,000 unit cubes that are 1 meter by 1 meter by 1 meter. So, describe the dimensions of a cube house using unit cubes. Remember that the edges of a cube are all the same length. Okay. What do I need to know? So to answer this, it's 1,000 unit cubes. Okay, this idea that they're 1 meter by 1 meter by 1 meter, that means that they're 1 by 1 by 1. The volume is going to be 1,000 because I can put 1,000 of these inside the house. Okay, so what numbers can I get? So remember, volume equals length times width times height is going to equal 1,000 units cubed, and these happen to be meters cubed. So I'm going to put cubic meters, okay? So I'm kind of pushing us into the future on this. It's a wacky question anyway, and it's worth it. So volume is 1,000. So I have to come up with numbers to get to 1,000. So I see 1,000, and the first thing I think of is powers of 10. How many zeros are there? There's 3, right? So 10 times 10 is 100, and 100 times 10 is 1,000, right? So I'm gonna go. Here's an example. Could be 10 times 10 times 10 equals 1,000 meters cubed, right? These are meters, 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 right? That's one example. Just gotta get to 1,000. Another example is pause this and think if you can get another one. Just try, how do I get to 100 and then multiply by 10? What's another way to get to 100? 25 times 4, right? So I could go, well, let's go 25 times 4 times 10. Well, 25 times 4 is 100, times 10 is 1,000. So I get 1,000 meters cubed. My point being here, volume is length times width times height. If they give you a volume, you just need to think of 3 numbers to get you to that volume. And so I would take that volume and see what number I can multiply, what 2 numbers I can multiply to get that number, and then take one of those 2 numbers and what 2 numbers can I multiply to get that number. I rewind and watch that again if you need to. But to work backwards, I need to find 3 numbers that will get me to that volume they give me, okay? So I go, what 2 numbers can I multiply to get that, right? And then what can I do with one of those numbers? I can pull one of those numbers out. Can I get 2 numbers multiplied to get that number? And then I'll have the 3 that I need, okay? Or you try and error, there's nothing wrong with that. Okay. The Nakagin Capsule Tower has 140 modules and is 14 stories high. If all the modules were divided evenly among the number of stories, how many modules would there be on each floor? So I've got 140 modules and it's 14 stories high. So that's 140, right? Divided by 14. 14 goes into 14 once. Hopefully most of you are seeing this already. Minus 14, I get 0. Bring down my 0 and I get another 0. And 0, blah, blah, blah. I get 10. So my question is, how many modules would be on each floor? There are 10 because 14 stories with 10 each gives me to 140, right? I always check my division with multiplication. That does make sense. And then how many different rectangular prisms could I get with that number? So what numbers can I multiply 3 of them to get to 10? Well, you can always start with 10 times 1 times 1, right? Because that's I know that's going to work. So one way would be 10 times 1 times 1 equals 10. Because 10 times 1 is 10, and 10 times 1 is 10, right? Okay. What's another one? So, like I said before, can I take 2 numbers and multiply them together and get 10? Yeah, right? 2 times 5 is 10. So another one would be 2 times 5 times 1 is 10. Now, are there any other numbers I can multiply to get 10 together? It's just 2, 5, 10, and 1. Those are the factors of 10. You got to know your factors, right? And so what I would want to do is, can I take either of these numbers and break them apart? Prime factorization kind of coming into play here. Can I multiply two numbers to get 5? I can't. Can I take numbers multiply to get 2? No, I can't, besides 1 and 2, right? Because they're both prime. If I have a number that's not prime, it'll work. In this case, I'm done. I can't break them down any further. Rewatch that part right there if I went a little fast, which is the beauty of having the internet. So pause the video, answer these, and let's see if we get the same ones. Boom. Okay, you're back. So I look at the first one and I go, that looks like a unit cube. That is 2 by 2 by 3. 2 times 2 is 4. 4 times 3 is 12. I get 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 if I count the cubes. So this first one is definitely 12. Remember, if there's 6 in front, there's 6 behind. It's also 6 plus 6. Okay, just remember that for a rectangular prism when they do this for you and they don't give you dimensions. This one we just count them. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. That's easy. And now look, on the bottom I've got 1, 2, 3, 4, 5, 6. There's 6 on the bottom and 1, 2, 3 on top. Right? 6 plus 3 is 9. This is my 9. Oh, that was kind of weird. All right, last video coming up. Homework.